Welcome to a lesson with Dr. Powell. Let's take a look at an example of computing the centroid of a thin wire. Suppose that this wire, which we will think about one-dimensionally, is given by this parametric representation, this parametric equation with an x equals something in terms of t and y equals something in terms of a parameter t, where the parameter t goes from -2 to 2 times the square root of 3. Now, when we're thinking about the centroid, it's the same thing as center of mass if the gauge of the wire or the density, the mass, whatever, is uniform throughout. So then it becomes a geometric question. So in this case, we will allow mass to be equal to simply arc length, or the length along the curve. So the total mass of the curve would be considered just to be as arc length, and a little piece would be considered to have mass just the length of that piece. Now, firstly, let's think about this. Since mass is going to be equal to arc length, or just kind of how far we are along here. Now, what's the rate of change of the distance along here with respect to a parameter t, if we think about t as being time? That's speed along the curve, right? So we could think about speed as having components in different directions. So the speed, so think dm dt as being speed, and then you have the speed in the x direction, you have the speed in the y direction, and then the way to compute the speed in this direction and along the curve is simply to think of this little Pythagorean theorem idea. So we actually get dm dt is equal to this square root, which we have seen before in calculating arc length. Now, so it's basically just the arc length derivative. We can compute this. The derivative of x with respect to t is simply 2, square it, we get 4. The derivative of y with respect to t is actually just t itself, and you square it to get t squared. So we end up getting that dm is simply this square root dt. So this is how to relate dm to an integral and dt. If this is our integral, it's done the same way as before if we're doing with areas, but we're just now thinking of instead of area, it's just arc length. So this right here is your dm. This right here is your x value. Notice that we got it from up here in the parametric equation. And then our total mass, so 1 over the total mass, where the total mass is actually given by the total arc length, which can be found right here, the definite integral of the derivative of arc length, and it becomes the change of the arc length function from here to here, which is the arc length overall. So this is how we compute the arc length. We just simply take the integral of dm, and that's how we get the total mass, or arc length, if you will. And that's what we put over here. So 1 over that, and then we compute this integral. Okay, in the next video, we will work on some of this integration here, but at least here we've discussed the setup for how we might compute the centroid along a wire. Thanks for watching.